Keegan.
And our senior project was the magnetic inspection automatic handling system. And this was through Tsubaki, which is an automotive company in Chicopee, Massachusetts. And they focus mainly on power transmission and motor control products, which include things like roller chains, sprockets, backstops, and clutches, which we included pictures over there. And the main part in our project was involved with roller chains.
All right, so this was our machine. It was the magnetic sorter machine. And like she just said, it dealt with the silent chain parts. So what this machine does is for one run, it takes 6,000 parts. And for those parts to go through the machine, it takes about 7-8 minutes. And so what it does, it throws the parts to the machine, and it goes to this box. And then once the 6,000 parts are done, the box kind of sits there idly and doesn't move until a worker comes over and starts on the process. And this is a video. I mean, it's kind of tough to see the parts because they're so little, but they're going straight through this machine down into this part, and the box is underneath. And this is another video. All right, so our project objective was to automate the handling system. So like I said, the boxes kind of sit idle until the worker comes over and starts the process over again. So our goal was to make it so that 12 boxes could go all at once without the worker having to come over. And so the worker wouldn't have to come over until about 60 to 90 minutes for each charge.
So when we started thinking about the design for this project, we realized that by going under the machine, that took a lot more to like scoop the box under manually. And then when we thought about putting automation in it, even having something go through that part of the box would be challenging. So we designed a chute that would bring the loading of the parts to the in front of the machine, so that when you put the box in whatever system we created, at least it would be all in front of the machine instead of having that obstacle. And we ended up doing a design that replicated the rejected parts chute, so that it would be at the same angle and type of acrylic material, so that we knew that the parts would slide through in the same efficient manner. Which then led us to do the actual design for the automation process itself. And we had a lot of different ideas, some in which had grabber arms, some that had push arms, some square designs that had rollers or conveyor belts. But a lot of that seemed like timing between pusher arms and having the other things would be more expensive or challenging. So the one that we liked was a turntable design, because that way we could put the 12 boxes on the table and then use a motor to underneath it to rotate the boxes. So it would be 12 empty boxes, and then they would turn and then fill the boxes 6,000 each until all 12 were complete, and then the worker could come over. So even that had many motor and turning options, like a motor and wheels, power rollers, stepper motor, but then we decided to do a prototype design, which ended up just using a standard servo with Arduino technology.
All right, so this was our turntable design. Like she said, we kind of mimicked the circle, but we did a 12-sided polygon. Since we wanted 12 boxes on our turntable, we kind of fill out the 12-sided polygon. And in this picture, something we also did to the turntable was add a mounting piece for the wheel, so that 4 wheels could attach to the turntable. And it was something we did in SolidWorks, and we used this 3D part. And then, like I said, the 4 wheels are on servo. So this was our automation for it. So the program we made in Arduino was to design the wheels to turn all at once, basically move forward. And we also had a counter and a sensor detector, so that the sensor detector for this would detect 6 parts, and the 6 parts would act on the counter. And then once the counter reaches 6 parts, it would signal the wheels to turn all at once. This right here is our final design. Like we said, it was a prototype, so our 12 boxes are on top. Here's our Arduino program that will move the servers. Any questions?
Has it actually been implemented?
Or to turn the table, yeah. We're still working on the counter to get it to turn. We
The
had it turning.
the Arduino's been implemented, but at the full scale, at the company been implemented with the turntable for that. Okay, how much did the full scale one cost?
Finally.
Yeah, well, at the company, they don't have the design yet.
So it hasn't been implemented?
No, it has not.
Okay, what would be the cost? Because you're not gonna drive it with an Arduino in industry usually, and it's gonna probably take more than 230 milliamps to turn a servo with the boxes on it, right?
Yeah.
So have you guys done an analysis on what it would cost? I mean, you're probably looking at a pretty basic PLC, some time, not much programming for this one. So you might want to include some analysis on that in the final report if you haven't done it already. And maybe you haven't, I just haven't seen it.
What does the magnetic sorting machine actually sort? Is it just looking for good and bad?
Yes.
It's literally just those little parts going through.
What's the ratio of good and bad?
Maybe per 6,000 parts go down, maybe like 3 of them go down to the.
Okay, so you don't have to have two turntables. Because
No, yeah,
the reject is a hell of a lot smaller than that.
That's why I had that one box, and that box really stays there a while. So
Well, how did they like your prototype design?
they liked it a lot, which I was kind of surprised that we just stayed at a prototype stage. But we did talk with them, and they said that like next year as a senior design project, maybe we'll have seniors do like the real physical one, now that we have like a prototype design.
You guys come back. When you come back next senior year.
Yeah.
Yes.
You'll just-
Thank you, guys.